right, so the second part of our lesson here is predicting with the line of best fit. So I want to start with a scenario to give us some data here. It's often said people who are good at math tend to be good at science too, and people who are good at English tend to be good at social studies. And you definitely have people who are a little more analytical or numbers make a little more sense to them. So, and math and science kind of go along with that. And then English and social studies involve a lot more reading, word skills, those kinds of things. So certain people do tend to gravitate towards those two kind of pairings. Personally, I believe that you can be good at whatever subject you really put your mind to it. I believe in a growth mindset where you are not fixed. You're not a math person or a science person or an English person. You're a learner, and all of us have to start somewhere. Some of us, it might take a little bit more work to learn specific things than others. For example, for me, math came pretty relatively easy, at least most aspects of math. But when I tried to learn a foreign language, it was very, very difficult. For you, learning a foreign language might be really easy, but math may be more challenging. But the reality is, all of us with the right amount of practice and some good teaching are capable of learning it. So understand that as we go in the context, that's beyond the context here, but look at our data here. We have 10 students who took an English and social studies exam, and we're examining this theory of being a English and social studies type of person by looking at the exam scores. And we're going to see, first of all, if there's a correlation. So we see the data. This first person scored a 54 on the English exam and a 65 on social studies. This person scored a 44 on English and a 58 on social studies, and so on, okay? All the way up to this person scoring an 82 on English and this person an 87 on social studies. Now, you can't just look at the numbers and say, oh, well, he scored 11 points higher on social studies, he must be better, because the tests aren't exactly the same. The social studies one might have been a little bit easier, or that maybe the types of questions were a little easier for them. So the question isn't, is everyone getting the same scores on both exams, but are they performing the same relative to each other on the exams? And that's where the correlation comes in. All right, so first of all, let's see if there actually is a correlation. So I already put the data in here in Desmos, and you can see, looking at the scatter plot, there does appear to be an upward trend. And so let's go ahead and find the linear correlation. So remember, we're going to do y1 and then the tilde mx1 plus b. And remember, that gives us this information right here, where we see our slope and our y-intercept for the line of best fit. I'm going to copy that real fast here, and then we'll look at it in our notes. Okay, so I'm going to come over here, and I'm going to put that, okay, whoop, that's really small. So let's examine this. I don't know why. There we go. Okay. So if we look at these values, we see that our line of best fit, we did this last lesson, our line of best fit is y equals 0.64, I'll round to 2 decimal places, x. Here, I'm going to round to here. The 5 says we round that 3 up to a 4. And then B is 29.517, so I'll make that 29.52. So our line of best fit is 0.64x plus 29.52. And this is the part we didn't do last week. This R value, the correlation coefficient that we just talked about today, R is a 0.9065. So we'll say 0.91. Again, rounding to 2 decimal points. All right. So notice here that our R value does show a strong positive correlation. If you recall, in our previous lesson, we looked at this number line here that falls right here in this strong positive range. Okay. Now, that means this model that we just came up with, the y equals 0.64x plus 29.52, is actually a pretty good model. It fits our data well. And in fact, if you look at the model graphed, you can see it's going right through. The data is pretty clustered around it very well. So we can see that this model, just by looking at it, is going to be a pretty accurate model. Okay, so let me put a copy of that in here as well. Okay, and again, we'll blow that up a little bit so it's a little more visible. Whoop. There we go. Okay, so we can see that a little bit better. Okay, now, what is this useful for? The whole point in making a model for our data is so that we can use that model to estimate other values. We're going to use the model to estimate other values. Lost my E there. Okay, so how do we do this? So there's two types of using the model here. One is interpolation and the other is extrapolation. Okay, now interpolation, if we look at the model that we're dealing with, interpolation deals with when we're given a value of x. First of all, it's got to be a value of x to be interpolation. But it's also one that is between what we call the poles, or it's within the range of the data. All right, let me make this a little bigger even still so we can see this. But if I'm doing interpolation, that means I'm given an x value that's between this and this. Our lowest x value was at 44. Our highest x value was 82. Okay, so there's 82. So if I want to know what would someone score on their social studies exam if their English score was something between 44 and 82, that would be interpolation. Okay, remember this is our English here, and up our y-axis is social studies. So here's an example. Jeremy scored a 78 on his English exam. So I'm going to use the line of best fit and approximate what score he's going to get on his social studies exam. So since my x coordinate is the English score, 78 is right here. So it's going to be this point on the line. Okay, well, if I punch in a 78, I'm going to substitute that into my line of best fit for x. So 0.64 times 78 plus 29.52. I can simply put that into my calculator. 0.64 times 78 plus 29.52, and that comes out to 79.44, or approximately a 79%. Okay, so someone who got a 78 on the English exam is probably going to get about a 79% on the social studies exam. That's interpolation because, again, this is inside the range of my data, okay? There's two types of extrapolation. Extrapolation, first of all, can be predicting the value of a y given the value of an x outside the range. So if I am anywhere to the left over here or to the right over here, that's extrapolation. And I will tell you here, extrapolation is not as reliable as interpolation, okay? Particularly, the further you get away from where your data was, the less accurate it's going to be. For example, here, our highest score was at 82. If I wanted to predict what someone who got 100 would get, my model's not going to be really accurate for that because that's extrapolating it well outside of the range. Same thing holds true for someone who got maybe a 20 on the English exam. It would be this point here, but that's way outside of where our data was, so that's not going to be a reliable prediction, okay? So extrapolation is not as reliable as interpolation, but it is possible, okay? So here we have Alma. She scored an 88 on her English exam. Now, this is not too far outside of our data range. So when we go ahead and find that, we do y equals 0.64 times 88 plus 29.52. And again, if we punch that into our calculator, that's going to give us 85.84, or approximately, if I round to the whole percentage, 86% on the social studies exam. Okay, so that's one type of extrapolation. When we are using a value outside, like this 88 over here. Okay. Now, there's another type of extrapolation, and that's when you're trying to figure out what x would you get if you were given a value of y, okay? Now, if you remember when we started looking at this, we said we're going to try to use x to predict y. If you're trying to use a value of y to predict x, that's another type of extrapolation. And again, it's not as reliable. So here we have Rakev. She scored an 80% on the social studies exam. So she scored an 80% here on the social studies exam. So using our line of best fit, we're going to let y equal 80%. Now, based on this, it looks pretty close to 80. Okay, let's see what happens here. This again is social studies, so we're going to let y equal 80, and I have that equal to 0.64x plus 29.52. So I've got to use some algebra. I'm going to subtract the 29.52 first of all, and I get 50.48. 50.48 equals 0.64x. And then I'm going to divide both sides by the 0.64. And you'll notice here x equals 78.875. Or I could say x is approximately a 79. So somebody who got an 80% on their social studies probably had gotten a 79 on their English exam. Okay, so that again is another type of extrapolation, not quite as reliable as interpolation, but it is possible to do. Okay, so The last thing I want to talk about here is interpreting the slope. How do you interpret what the slope represents? So that's a big thing here in correlations. Slope is the change in the y value over change in the x value. Okay, remember slope is rise over run. Rise over run. So the rate of change that slope represents will always be whatever the units of y are per the unit of x. Okay, and I actually should just say unit of x because we're going to make it out of one unit. So in this case here, the slope equaled 0.64. Okay, now if you remember your y equaled the percent on the social studies exam. The x is the percent on the English exam. So what does this 0.64 mean? That means for every 1% on the x, for every 1% higher your score is on the English exam, you score 0.64% higher on the social studies exam. Okay, so if I'm looking at this as a rate, I would say 0.64% on social studies per percent on English. Okay, so that word per that we use for rates of change, like miles per hour, okay, that we can use here. But what that represents here is that for every 1% higher score on the English exam, you're scoring approximately 0.64% higher on the social studies exam. That's what we're saying. Okay, move that down a little bit. Okay, so that is how we can use the model. First of all, for interpolation and extrapolation, and then also when we're looking at the slope, that's what that slope represents in the context of the problem.